Okay, example 2, right? Determine whether these equations represent functions or not. Okay, in order to tell, first you need to solve for y. Right, so on the letter A, if I subtract x squared, I have y equals 1 minus x squared. On letter B, I have to add x. So y, oh, that was x. So y squared equals x plus 1. Right? And then as a last step, I have to take the square root of both sides. Okay? What do I get when I take the square root of x plus 1? You get the square root of x plus 1, almost correct. Plus or minus. It has to be plus or minus. So notice the difference between these two examples, right? In this one, every time you plug in a value of x, how many values of y do you get? You get 2. You get a plus and a minus. Right? So there's 2 answers. That's not a function. Right? This means 2 values, 2 y values for each x value. So not a function. Okay, this one, right, you don't have the plus or minus. Every time you plug in a value of x, how many y values do you get? 1. That's a function. Now, I think there's like 6 problems in the homework that do this, right? Do you really have to solve for y to tell whether it's a function? No, just look for a squared term. Or anything raised to a y to an even power. If there's a y to an even power, it's not a function. Otherwise, it is. For the most part. Saying that, like, I wouldn't really have to solve these. I just look at it here and say, oh, that's a y to the first. That one will be a function. This one, I would come over and say, oh, it's y squared. Okay, that's not a function. Because I know that on the last step, I would take a square root and introduce a plus and a minus.